Chapter 4.3, Solving Quadratic Equations by Completing the Square. Many quadratic equations cannot be factored. When graphing, we cannot always find the exact solutions. Completing the square gives exact solutions to a quadratic equation that is not factorable. We went over the steps for completing the square in Chapter 3.3, so you can reference that. And you would use solving equations by completing the square either if you're asked to solve by completing the square or if you want exact solutions and your quadratic is not factorable. Example, solve x squared plus 6x plus 4 equals 0. So obviously we're going to solve all of these by completing the square. So to complete the square, step 1, we group the x squared and x terms together, so we get x squared plus 6x, leave a space, close the bracket, put the constant outside, equals 0. Step 2, that's where if there's a number in front of x squared, you factor it out, but this is just a 1, so we don't have to do anything. So we go on to step 3. Step 3, we take the second term coefficient, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. Step 4, we add the 9 in the space in the brackets and subtract it outside. So x squared plus 6x plus 9, close bracket, plus 4, and we subtract 9 because we can't just add 9 to the equation and have it be the same equation. So if we add 9 inside the brackets but subtract 9 outside the brackets, then we've really added nothing. And remember that if there was a number that we factored out of the brackets, something here, we would have to multiply this minus 9 by that number as well. Step 5. The trinomial is now a perfect square trinomial, so we factor it down to a binomial squared. Square root of the first term, x squared, is x. The square root of 9, the last term, is 3. And the sign for the binomial comes from the sign from our middle term, which is positive 6x, so positive x plus 3, and then that binomial is squared. And then the outside, positive 4 minus 9 is negative 5 equals 0. So that's what we did in 3.3, and that's where we stopped. Because we didn't actually have equations in 3.3. We didn't have that these quadratics were equal to anything. We just had functions. Now we have equations, and we're trying to solve for what x equals. So that's the next step. Solve x plus 3 all squared minus 5 equals 0. We want to isolate x. We'd start by moving over the 5, adding 5 to both sides. We get 5 on the right and x plus 3 all squared on the left. Then we need to get rid of the square by doing the square root. But we don't know if these brackets were a positive number and then squared, or if they were a negative number and then squared. Because either way we would get a positive. So we have to account for both cases by doing plus minus the square root of x plus 3 squared equals plus minus the square root of 5. Then on the left side, we can just drop the square root and the squared, and we just have x plus 3 On the right side, we have plus minus the square root of 5. And finally, we subtract 3 from both sides, and we get x equals plus minus the square root of 5, and then minus 3. Notice the minus 3 is not under the square root because it was a constant term. There was no square root with this minus 3, so it cannot go under the square root. It has to be outside the square root. We can't simplify this any further, so this would be our solution in exact value. Notice that we have two solutions. We have when the square root of 5 is positive, so positive square root 5 minus 3. And we have when the square root of 5 is negative, so negative square root 5 minus 3. We can write it like this, where it's just both solutions are written in one, or you can separate it into two and write it as x equals positive square root 5 minus 3 and x equals negative square root 5 minus 3. So again, these are the solutions written as exact values. Which means if we want an exact value, we are not going to calculate. So don't calculate. If I put this into my calculator, I'm going to get a decimal number, and that's going to be a rounded answer. So if I want the exact value, I usually will have a square root in my answer, unless it happens to work out to be a perfect square. Example, solve x squared plus 8x plus 8 equals 0. Step 1. Group our x squared and x terms together. X squared plus 8x, leave a space, close the bracket, put the constant outside, and then equals 0. Step 2, if we have a number other than 1 in front of the x squared term, we factor it out of the brackets, but we don't, so we go on to step 3. Take the middle term coefficient, divide it by 2, and square it. 8 divided by 2 is 4. 4 squared is 16. Step 4, put that number back in by adding it inside the brackets, plus 16, and subtracting it outside the brackets. Step 5, simplify and factor the trinomial. Factors to the square root of x squared is x, square root of 16 is 4, the sign from 8x is positive, and that binomial is squared. 8 minus 16 is negative 8, equals 0. So we've put it into vertex form by completing the square. Now we want to solve for x. Add 8, we get x plus 4 all squared equals 8. We want to get rid of the squared, so take the square root of both sides. But again, because we don't know if x plus 4 started as a positive or a negative, we have to do plus minus the square root on both sides. Then on the left, we can get rid of the square and the square root. We're left with x plus 4 equals plus minus square root of 8. then subtract 4, and we get x equals plus minus the square root of 8 minus 4 outside the square root. Now, we can simplify this square root. Thinking back to Math 10C, how do we simplify a square root? When we look at the perfect square numbers, I'm going to write those over here. Perfect square numbers. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on. To simplify a radical, we find the biggest perfect square that can divide the number under the radical. So we have 8. What's the biggest number from this list that can divide 8? That would be 4. 8 divided by 4 is 2. So we can write this as x equals plus minus the square root of 4 times 2 minus 4. Then the number that came from our perfect square list can be square rooted and taken out. The square root of 4 is 2, so I get x equals plus minus 2 square root of 2. This 4 came out and became a 2 because the square root of 4 is 2. And then this 2 is still left under the square root. And then we have minus 4 after. So this is our fully simplified exact solutions. And you always have to fully simplify your answer. Just like with fractions, when you have a radical in your answer, you need to fully simplify it. So let's put a note here. Simplify the radical. Example, solve 2x squared plus 8x plus 5 equals 0. Step number 1, group your x squared and x terms in the brackets. 2x squared plus 8x, leave a space, close the bracket, constant goes outside, equals 0. Step 2, this time we do have a number in front of x squared, so we're going to factor that out of the brackets. 2 bracket x squared plus 8x divided by 2 is 4x. Leave a space, close the bracket, plus 5 equals 0. Step 3, take our middle term coefficient, 4 divided by 2, and square it. 4 divided by 2 is 2. 2 squared is 4. Step 4, add and subtract that number. 2 bracket x squared plus 4x plus 4 plus 5 outside the bracket, and then minus 4 outside the bracket. But because we factored something out in step 2, and we now have this 2 in front of the brackets, we need to multiply this minus 4 by 2 as well. So negative 4 times 2. And step 5, let's simplify. 2 times the binomial x plus 2. Square root of x squared is x. Square root of 4 is 2. The sign from the middle term is positive. That binomial is squared. Then we have plus 5 and minus 4 times 2. Minus 4 times 2 is minus 8. Positive 5 minus 8 is negative 3 equals 0. I forgot that here. Okay, now we want to solve this for x. Start by adding 3 to both sides. Then we get 3 on the right and 2 times x minus 2 squared on the left. When we have a number being multiplied to the brackets, we have to divide that to the other side first. Then we get x minus 2 squared equals 3 over 2. Now we want to get rid of the square, so we have to square root. And again, we're going to do positive, negative square root of both sides. Then we get x minus 2 equals positive, negative square root of 3 over 2. And then we add 2 to both sides. And we get x equals the square root, positive, negative square root of 3 over 2 plus 2. And can we simplify this radical? Are there any perfect squares that divide 3? No. Our smallest perfect square number is 4. Are there any perfect squares that divide 2? No. Our smallest perfect square is 4. So this is fully simplified and written as an exact value solution. Example, solve 4x squared plus 10x plus 5 equals 0. Step 1, group our x squared and x terms together. 4x squared plus 10x, leave a space, close the bracket, plus 5 equals 0. Step 2, factor out the number in front of x squared, which is 4. 4 bracket, that leaves x squared plus 10 divided by 4. We can reduce that fraction. 10 over 4 equals 5 over 2x. Leave a space, close the bracket, plus 5 equals 0. Step 3, take our middle term coefficient, which is 5 over 2, and divide it by 2, and then square it. That becomes 5 over 2. Dividing by 2 is the same as multiplying by 1 over 2. And then square, so 5 times 1 is 5, and 2 times 2 is 4, and that's squared, which gives us 5 squared is 25, and 4 squared is 16. You can also just use your calculator and plug in this, and it'll give you this. Step 4, we're going to add and subtract that number, so 4 bracket x squared plus 5 over 2x plus 25 over 16, close bracket, plus 5 minus 25 over 16, and then times 4, because that's been factored out of the bracket. So times 4 equals 0. And step 5, let's simplify. 4 bracket, the square root of x squared is x. The square root of 25 over 16, square root of 25 is 5. Square root of 16 is 4, so 5 over 4. The sign from the middle term is plus, so plus, close the bracket, that binomial is squared. Then I'm going to use my calculator for the constant. We have 5 minus fraction 25 over 16, move out of the fraction, times 4. That gives me negative 5 over 4. Now we need to solve that for x. Add 5 over 4 to both sides. We get 4x plus 5 over 4 squared equals 5 over 4. Then we have a coefficient in front of the brackets. We need to divide both sides by that. We're left with x plus 5 over 4 squared equals 5 over 4 divided by 5 over 4. That's 5 over 4 times 1 over 4, so 5 over 16. You can also just plug it into your calculator. Math, fraction, 5 over 4 divided by 4, 5 over 16. Then we want to square root both sides. And again, we don't know if it started as a positive or negative, this binomial. So we do positive, negative, square root x plus 5 over 4 squared equals positive, negative, square root 5 over 16. Then the left side is x plus 5 over 4, and the right side is plus minus square root of 5 over 16. Now we can simplify the radical. We have square root of 5 over 16. We can look at them separately. Square root of 5, can we simplify that? Our smallest perfect square is 4, which does not divide 5, so no, we can't. Can we simplify square root of 16? Yes. 16 is a perfect square number. The square root of 16 is 4. So we can write this as x plus 5 over 4 equals positive, negative, square root 5, because I can't square root that one, over 4. Square root of 16 is 4, so now 4 is not under a square root. And then we want to subtract 5 over 4 from both sides. So we get x equals positive, negative, square root of 5 over 4 minus 5 over 4. Let's write that in one fraction. We have the same denominator, so we don't have to make a common denominator. It would become x equals positive, negative, square root of 5 minus 5 divided by 4. And then last step, we just want to check if there's any coefficients that can be divided out. So the number in front of the square root is a 1. Then we have a 5 and a 4. Those are our coefficients. If those three values have a common factor, then you divide out that common factor. In this case, there's no common factor between 1, 5, and 4, and our radical has been fully simplified, so this is our final answer. An example of what to do if you do have a common factor, let's just say that we have x equals plus minus 4 square root 3 minus 6 divided by 8. If we look at our coefficients, which are the number in front of the square root, and then the constant terms, 4, 6, and 8, they can all be divided by 2. So we divide those all by 2. This does not affect the number under the square root, just the number in front. So we get plus minus 4 divided by 2 is 2. Square root of 3 minus 6 divided by 2 is 3. Divided by 8 divided by 2 is 4. And then that would be our fully simplified answer. So we had a common factor of 2 for all of our coefficients, which were the 4, the 8, and the 6. Example, the length and width of a rectangle are 6 meters and 4 meters. When each dimension is increased by the same amount, the area of the new rectangle is 50 meters squared. Find the dimensions of the new rectangle. Round your answer to the nearest tenth. So start by drawing a rectangle. And the dimensions of this rectangle are 6 meters and 4 meters. So 6 meters, 4 meters. Then it says when each dimension is increased by the same amount, so we're adding to the length and width of the rectangle. So let's say that we do this. We add this way to the length, and then we add this way to the width. And it says that they are increased by the same amount. So let's call this increase x. Then it tells us the area of the bigger rectangle. We know that area formula is length times width for a rectangle. And they say that this rectangle, the bigger rectangle, has an area of 50. So 50 equals length times width. What is the length of the big rectangle? It started as 6, and we increased it by x, so it'd be 6 plus x. What is the width of the bigger rectangle? It started as 4, we increased it by x, so it'd be 4 plus x. We need to have a quadratic in standard form before we can complete the square, so multiply these two binomials together. 6 times 4 is 24, so we get 50 equals 24. 6 times x is 6x. X times 4 is 4x, and x times x is x squared. Combine like terms and also move the 50 over. So I'm going to subtract 50 from both sides. And I get 0 equals, I'm going to put the x squared term first. So I have positive x squared. Then my x terms, I have 6x plus 4x, so plus 10x. Then my constant, which was 24 minus 50, which is negative 26. Now I have a quadratic equation, and my quadratic is in general form, so I can complete the square. Step 1, group the x squared and x terms together. Leave a space, close the bracket, put the constant term, and I'm going to move the equals to 0 to the right. Step 2, is there a number in front of x squared? No, so we don't have to do step 2. Step 3, take the coefficient on the x term, divide it by 2, and square it. 10 divided by 2 is 5. 5 squared is 25. Step 4, put that number back in, x squared plus 10x, add it inside, so plus 25, close the bracket, minus 26, and subtract 25 outside. Step 5, factor and simplify. The binomial is x plus 5. Square root of x squared is x. Square root of 25 is 5. Middle term sign is positive. That binomial is squared. Negative 26 minus 25, that would be negative 51. And that's equal to 0, and that's equal to 0. Now that we've completed the square, we want to solve for x. X plus 5 squared minus 51 equals 0. Add 51 to both sides. We get 51 on the right and x plus 5 squared on the left. We want to get rid of the squared, so we need the square root. We have to do plus minus the square root, since we don't know if x plus 5 started as a negative or a positive. That leaves us with x plus 5 on the left and positive, negative, square root of 51 on the right. Subtract 5 from both sides, and we get x equals plus minus square root of 51 minus 5. Then from here, we don't need to check if we can simplify because the question says round your answer to the nearest tenth. So it's telling us that we are not going to give an exact value answer. We're going to actually calculate this. So now we just bring up our calculator. And we have the positive square root of 51, and then move out of the square root and put minus 5. Enter, and that gives us 2.1414 ... Rounded to the 10th would be x equals 2.1. And then if we do the negative, we get negative square root of 51, move out of the square root, and then minus 5. And we get x equals negative 12.1414 ... Rounded to the 10th would be negative 12.1. It's a word problem, so we need to write a statement. The question says, find the dimensions of the new rectangle. So our two answers are x equals 2.1 and x equals negative 12.1. What is x again? X is the amount that we're adding to the rectangle to make the length and width bigger. It doesn't make sense to add a negative number, and it definitely doesn't make sense to add this number because that would actually make our length and width negative numbers. So we can't have this. This is not a possible solution since we can't have a negative length or a negative width. That means that x equals 2.1 is our solution, but the question is asking for the dimensions of the new rectangle. So we have to do the length equals 6 plus x, which is 2.1, which equals 8.1, and the width equals 4 plus 2.1, which is 6.1. So our solution, length equals 8.1 meters, and width equals 6.1 meters. That brings us to the end of Chapter 4, Lesson 3.